Right now, the industry is locked in a shouting match over who has the smartest chatbot. Every week, a new firm claims they are winning the artificial intelligence race. But measuring success by looking at a standalone app assumes we are dealing with a standard consumer product. Google is treating AI as an infrastructure problem, quietly building a physical pipeline that bypasses the noise of the product battle entirely. This animated blueprint shows a 4-layer stack. Breaking the technology down into these 4 specific tiers is the only way to map out Google's actual strategy. While competing firms are fighting over who can build the fastest car, Google is acquiring the roads, the gas stations, and the manufacturing plants. Whoever controls these underlying layers will dictate the future of the entire industry. This image shows the physical reality of artificial intelligence. Layer 1 is power and infrastructure, housed in massive sterile data centers. Google is pouring capital into custom-built TPUs and a global network of planet-level compute. A TPU, or Tensor Processing Unit, is a specialized hardware accelerator designed specifically to speed up machine learning workloads. There is an ongoing debate in the tech sector over whether this scale of compute power is actually necessary, or if it is a massive waste of capital. Looking at our blueprint, this solid foundation of power represents a contrarian bet. Google believes their infrastructure is still not enough. Directly on top sits Layer 2, the brain, where models like Gemini serve as the logic engine. Instead of launching loud, standalone bots to grab headlines, Google is focusing on reasoning and integrating these models quietly across their existing ecosystem. They are building Gemini with multimodal capabilities. Multimodal means the model can simultaneously understand, operate on, and combine different types of information, like text, code, audio, image, and video. A highly capable model is useless if it doesn't rest on an infinite proprietary power supply directly beneath it. Moving up the stack, we reach Layer 3, platforms and tools. Raw logic models must be converted into systems that developers can actually use. This image shows a developer's workstation, which is where platforms like Vertex AI and AI Studio operate. This layer acts as an assembly line. It dictates exactly how fast builders can experiment, test, and deploy real-world applications to the public. As our diagram shows, these platforms rely completely on the models and compute beneath them. The stack is finished by Layer 4, wrappers. This user layer is the final terminal where raw compute meets the consumer. This layer includes familiar surfaces where AI is being injected: Google Search, Docs, Gmail, Chrome, and experimental tools like Notebook LM. These additions serve a mechanical purpose rather than functioning as simple product updates. They are pre-existing entry points. By placing AI directly into tools people already use, Google immediately forces interaction from billions of daily active users. Google doesn't need to convince anyone to download a new application. Their distribution network simply activates the technology right where you already are. This completed diagram illustrates the full pipeline. Raw compute generated at the very bottom flows directly upward through the models, into the platforms, and out into mass distribution. Competitors who build highly capable models still have a major vulnerability if they are forced to rent their physical compute power from an outside provider. Likewise, a company can engineer brilliant software, but if they lack a built-in distribution network, they have no guaranteed way to put it in front of users. The focus is no longer on the best standalone model. It's on who owns the pipeline from the data center to the end user. In the push for industry dominance, the serious capital flows to a closed-loop monopoly. And right now, no one is closer to that reality